Good afternoon, everybody. My name is Juan Rodriguez. Today I'm going to talk about MapT. So I'm going to give you a small recess on SRv6 and AI for the next 15 minutes. So I run the service providers for North America from the business development and consulting engineering perspective. So today we want to talk about what is MapT a little bit, and a few experiences and what we are seeing in the field regarding MapT. A quick intro regarding this. As mentioned before, this is not an SRv6 presentation, neither an AI presentation. I'm not going to be going through the IPv6 basics. As Latif mentioned, IPv6 is here. Everybody should be aware of what it is, how it works, etc. Neither a transition overview. There are multiple transitions out there. Multiple people have been doing different options. I'm not here to tell you it was right or wrong. We all know, depending your use case, you will have different opinions and different way of doing it, especially when did you start, how many v4s you have on your network. And also, I'm not planning to do any of those comparisons, right? Keep in mind, the focus of this session is to talk about the application layer. This is not about your infrastructure. So this goes hand in hand with all the presentations you guys have seen today about SRv6. So this is how you move your network out of v4, or basically dual stack, and offer v6 to your end customers, right? Now, what is this presentation about? As mentioned before, I plan to go a quick overview what MapT is, what other customers already are doing, multiple type of customers, service providers basically, cable operators, tier 1s, tier 2, how they did it, why they did it, okay? Keep in mind, again, depending the region where you are, few of you, especially service providers, you were lucky enough to have enough before. A few others were like, I need to buy more before. Maybe my business case is simpler just to buy before. I don't know how much you guys follow the price of IPv4 these days. A couple months ago, it was extremely expensive. Then a few weeks ago, I was checking before this. It went really, really low. So right now, we're talking about around $30, 30 US dollars per IP. A couple months ago, it was 50. A couple years ago, it was 70 per IP, depending how much you buy, right? So let's go into it. By the way, quick favor, who on the audience has been hearing or deploying MapT? Nobody? Few? Good. Few? Good. Okay. Quick overview on what it is. Map, when we talk about it, is mapping address and port. MapT is something that is not new. MapT, the map itself, the RFC started, the draft started around 2012, 2013, became RFC around 2015, and then we started developing it and having ready a production environment in 2017. So nothing new. I just want to highlight how important, how mature the technology is today. So two key elements when we talk about MapT. The first one is the CE, Residential Gateway, CPE, depending on how you guys call it, sometimes even the set-top box, depending on your configuration. And then the border relay. The border relay, we're going to cover it in more detail later. The border relay, or if you guys call it border router, at the end, when you go, if you go on the RFC, it's called border relay. What makes MAP different than every other technology, transition technology out there is it leveraged the inherent capabilities of the routing of the IP addresses. So the secret sauce of MAP, doesn't matter if it's MAP-E, MAP-T, is the MAP algorithm that leverage all the IP address capabilities to do the translation. Having said that, it is stateless. I don't remember who was talking this morning about all the latency that NAT add to the traffic, obviously, because you need to have a state on your NAT PE or your NAT appliance. In this case, MAP is 100%, well, 99.95%, I will cover that later, is stateless. So it will help you to scale way faster, way simpler and cheaper than any other technology out there. Now, two versions of map are being deployed, right? We have map E, as you guys can see the RFC, if somebody wants to go and take a look at the RFC later. Use v4 into v6 encapsulation to transfer the v4 packets over v6. We're not going to be talking about map E. And then we have map T that use translation between v4 and v6 to basically transport v4 over v6. Now, let's go a little bit deeper into what it is, right? So as mentioned before, we have, as you can see, from the left, we have DCE all the way to your access aggregation. Remember, when I say access aggregation, could be cable operator, could be a telco, I don't care. As long as that is IPv6, that's okay. Now, going bottom to top, the most important thing here, guys, is any traffic coming from the application, v6, native v6 will go IPv6 routing natively and all the way to the intranet. I will say the nicest thing here is you start removing v4 from your network. You start removing the need for dual stack. Anybody who has operating a network understands how tricky, how cumbersome it is to deal with dual stack. In this case, you start having a true native v6 out there. Now, the second row, as you guys can see, we have map T, the CE. Remember, the tricky thing about map T, and my personal opinion, the only drawback we are seeing in the field with map T is the CE support. It's getting more and more popular, but it's still a key differentiator that you need to have, and I will talk about that later. So this map TCE will get the IPv6, sorry, the IPv4 that we assign normally, the public one, but also will assign a specific port range to that public IPv4, and then it will be translated, okay, again with the map algorithm, into the v6 header, okay, into the IPv6. So it will use a specific bits into the v6 to go natively, and when it gets to the VR somewhere, we will talk about options on where to put it, it will go back into v4. Now, something that I believe I forgot to highlight is one of the other things that make map T special is it will help you to interwork, not just transition. It will interwork with your v4 only OSSs, BSSs that you have on your network. Let's be honest, guys. We all have been here. Everybody has been deploying a network. Somewhere you have few appliances, few old things that are out there that do not support v4. So what MapT is going to allow you is find a way to start transitioning all the things you can to v6 while it's still dealing with your v4 network until, and let's be honest, the business case allows you. It's not the technology. This is not a technology thing. We all here, maybe most of us are geeks, and we know we can just configure on v6. It's all the things that come when we want to move a network to v6, and do I have the budget to do that? How much money do I bring to the table? How much is the finance team allowing me to do that, or do I need to do something else? So those are the key things that MapT helped me to do the interworking. Okay, so why? What makes MapT special? As mentioned before, it's a stateless. When we talk about the stateless, it means scale. Think about a couple tens or maybe hundreds of tera running in a router with v4 to v6 translation. Now, translate anybody who has NAT in your network, how much will it cost to have tens of tera running on your network? Secondly is it supports asymmetric traffic. It will follow, again, because it's stateless capabilities, it will follow just the routing. As long as you configure the routing rules and mapping, it will just flow with the routing, right? Now, another thing that we all have been dealing with does not require traditional logging. So it's log, radius, whatever you guys have. In this case, you just do the reverse mapping somewhere, and that's it. Now, advantage, as mentioned before, I think I had gone into it. It's cheaper, reduced complexity, better scale, better performance. Now, when we talk about trade-off, let's be honest, it's not going to be a technical discussion without talking about trade-off. Requires supports on the CE. You're going to have a fixed port allocation of those ports out there. And when you do the V4 to V6, you will get overhead. If you don't have a right design on your network, you may have a few MTE issues. Okay? So, how can I deploy it? 4 models of deployment. I can go cloud native, I can go with VNF, CNF, I can deploy whatever I want. Right now we have a customer where they deploy MAPT on the border relays close to the pitting. They say, hey, I have a lot of compute close to my subscribers, and part of their edge cloud, edge compute, however you guys want to call it, they plan to load a few containers to do MAPT on a small market. Appliance-based, you get an appliance and it will trade as a traditional appliance out there, or then integrated that goes directly into the router, and my favorite is a hybrid approach. Hybrid means maybe the big markets, I have a big router, small market is medium, et cetera, et cetera. So let's go to the details here. This is one of my favorite slides. This was actually our first customer who deployed MAPT. Think about this. We started working together on this 2017. They went to the field 2020. Somebody may ask, why 3 years? We went and do it for things. So we went, we did DVR, everything was great. They started finding issues on the CPE, and then some issues also with LI. They were able to solve it with free scripting. As you guys can see, you have the CPE support. We start working with the CPE vendors. Traffic goes natively all the way to the routers. So imagine the cloud on the left is a market. Imagine a couple million subscribers per market. It will hit the PEs on the market header, and then they had an appliance just for data path, and then another appliance just for exceptional traffic. When we talk about exceptional traffic, we're talking about TCP, fragmentation, and fragmentation and ICMP. Another customer, they basically allocate the BRs in the PEs for market header, on the market headers, and every traffic go through it, everything following the routing path. Last but not least, this is a tier 2. This is actually my favorite approach. They have their backbone, and they deploy the BR on the pitting routers. So instead of using another appliance, another router to do it, they do it in line with the router. Now, lessons learned. I know I'm running out of time. The border router, the border relay is the easiest path to deploy MAPT. Super simple. Keep in mind, you will add latency. Again, as the previous gentleman highlighted, you will have imposition for monitoring and policing. Now, CPE is where you need to start having these discussions. Is my CPE supporting MAPT? It's getting more and more traction out there because MAPT is getting more traction over there. Do I support things like BCP38? BCP38 is the anti-spoofing mechanism everybody uses these days. Does your CPE support port overload? Can I use additional ports to subscribers, right? Now, lessons learned. When we started this, we thought we were going to have way more exceptional traffic, way more fragmentation. At the end, what we noted, this is a real-life example of 70 to 80 tera per second network. 99.95 of traffic follow the data path, and just 0.05 traffic goes to the exceptional traffic, to the exceptional appliance. Under DDoS attack, they basically get 0.15% of the traffic going to the fragmentation and exceptional traffic. So at the end is, you need to have that additional capability, but it's not such a big deal. Planning and preparation. How will you allocate those rules? Do you want to have one rule for the entire network, multiple rules for smaller markets? It depends. As mentioned before, OSSs and BSSs, those are the most challenging one. And then lawful intercept. What we're seeing, everybody, they just create scripts. They're just good at subnetting. They create scripts, and they're able to do the translation back into V4. Last but not least, the conclusion here, any question you guys, we can talk later on the booth, but MAP-T, IPv4 is a business case at the end, guys. IPv6, sorry. It will depend how many V4s you have. We're seeing customers deploying MAP-T to sell the IPv4s they have available. Others, they just say, I need to deploy this because I don't have enough before. So it will depend in your case. We're here to help. MAP-T is a mature technology. So we have multiple customer already deployment. So having said that, I think that's it, right? Do I have time? Looks like not.